Hi, in this video I'm going to go over how to find an equation of a line. And so I just want to recall one definition. So if we have a line and we take any 2 points on that line, it doesn't matter which two, they just need to be different points, and we're going to call them x1, y1 and x2, y2, then the slope of the line is y2 minus y1 over x2 minus x1. And many times you'll see the slope referred to with this lowercase letter m. So that's our formula that we will use. The remarkable thing about a line, and this is unique to a line is the only kind of graph that satisfies this, is that it doesn't matter which 2 points we take as long as they're different, that this slope will always be the same number. So let's do an example. So let's graph the line with slope -1/2 that goes through the point 3, 1. After we graph this line, we're going to find an equation for this line. So if we want to graph it, we need some axes. And we know that this line goes through the point 3, 1. 3 being the x-coordinate and 1 being the y-coordinate. So we need to use the fact that the slope is -1/2. So if we go back and think about what the definition of slope is, it is how the y changes divided by how the x changes. So if our slope is -1/2, that means every time the y changes by -1, meaning the graph goes down 1, then the x value increases by 2. Every time the y value decreases by 1, the x value increases by 2. So in this case, if we decrease by 1 in the y direction, then we increase by 2 in the x direction, and we end up right here at the point 5, 0. We could do this again. If we decrease by 1, we increase by 2, we end up right here at the point 7, -1. Also, if we instead write this number as 1 divided by let me retry that. If we rewrite this as 1 divided by -2, 1 divided by -2 is the same as -1 divided by 2. This tells us that if we increase by 1 in the y direction, then we go -2 units in the x direction. So if we go up 1, we should go in the negative x direction, which is left 2. So, there's where we are. If we went up 1, then we should go right 2. So here's another point. There we go. So now what we want to do is connect all these points. So we could start here, start right here, and go this way. We could start there, and go the other way, and there is our line. Okay, that is the line with slope -1/2, and it goes through the point 3, 1. So you'll notice that there are many other points. For instance, we've got this point here, and what is that point? That point is the point 2, 1.5. And how would we get that from 3, -1? Well, we could start at 3, -1, or 3, +1. And if we decrease the x value by 1, we could rewrite this as, this is the same thing as 1/2 divided by -1. So if we decrease the x value, by -1, we increase the y value by 1/2. And these two are equal as fractions, and that's how that occurs. Okay, so let's see what else. Let's also take the slope of -1/2 and the point of 3, 1, and notice that if we have any other point on the line, let's say we have the point xy is any other point on the line, or x1, y1, any other point on the line, then I know that if I do y minus 1 divided by x minus 3, I should get -1/2. And that's because this slope is constant no matter what 2 points you take on the line. If I take the difference in their y values divided by the difference in their x values, I should get -1/2, which is remarkable. So if I wanted to describe all x, y points that are on this line, I would say y minus 1 over x minus 3 equals -1/2. And that is true. That is true for every single point on this line, except for the point 3, 1, because if I input 3 for x and 1 for y, I get 0 over 0 on the left-hand side. So I want to somehow account for the fact that 3, 1 also works. So what I'm going to do is I'm going to take this equation here, and I'm going to rewrite it as y minus 1 equals -1/2 times x minus 3. See what I did there? I multiplied both sides. Oops, excuse me. I multiplied both sides by x minus 3. And on this left-hand side, the x minus 3's cancel, and I was just left with y minus 1. So every single point on this line satisfies this equation. And in fact, a point is only going to satisfy this equation if it's on that line. So this gives me an equation for the line with slope -1/2, and that goes through the point 3, 1. Now, this may or may not be different than something that you've seen before, but this should be very similar to what we call the point slope formula for finding an equation of a line. Okay, so let's suppose we have a line with slope m with point x1, y1 on the line. So I put m and x1, y1 in purple, so I'm trying to indicate there that those are numbers. So you should have really you should have numbers there. So for example, in the last example, we had slope -1/2 with point 3, 1 on the line. So those were all numbers. Then y minus y1 equals m times x minus x1. Again, where we're filling in numbers for y1, m, and x1. Then this equation is an equation for the line. And this is called the point slope equation. It's the point slope because you have a point and you have the slope. Here's our formula for the point slope. Okay, if we go back and look at what we got here, our -1/2 was m, and 3, 1, that was our x1, y1, and it has the exact same form as what we got. And the reason that this point slope formula works is for exactly the reasons that we just outlined. We took the definition of the slope and we constructed our equation for our line. Okay, let's do one more example of the same line, but finding a different way to find an equation for the same line. So we're going to start with the same information. M equals -1/2, and 1 point on the line is 3, 1. And we're just going to show a different way to find that equation for the line. Both are totally valid. Sometimes one is more helpful than another. Notice on our point slope formula, all we had to do is take these numbers and fill them into our equation. -1/2, 3, and 1, and that will give us an equation for the line. Okay, our other way of doing this is y equals mx plus b. This is known as the slope-intercept form of the line. And in this case, again, the purple letters are supposed to be numbers. And we need to, the problem is here is that we need to figure out what these should be. In this formula, m is the slope. So since I know the slope, I can just fill that in. So y equals -1/2 x plus b. On the other hand, this b value, that's not readily available. We have to figure out what that b value is. We can't just input 3 or input 1. We've got to figure out what it is. Okay. So what we're going to do is we're going to recognize the fact that 3, 1 is a point on this line. So in other words, when x is 3 and y is 1, we get a true statement. So we should be able to fill in the x and the y, 3 for x and 1 for y, and we end up getting 1 equals -1.5 plus b. And then solving for b, we get b is 2.5, which leads us to our formula, y equals -1/2 x plus 2.5. That would be another formula